Hello friends, welcome to our YouTube channel KG Foundations. So today we'll be learning the very first topic of class 11, that is sets. Now what are sets? A set is a well-defined collection of objects. So whenever we say that we categorize a certain number of objects under a particular category, so that is known as a set. Now in order to represent a set, we have two types. One is the roster form and the other one is the set builder form. Now what is a roster form? A roster form is a form in which all the elements of a set are listed and are separated by commas and are included within braces. For example, let us say we have A, E, I, O and U. So this particular representation is known as the roster form, in which we have a certain number of elements which are separated by commas and are enclosed within braces. So this particular form is known as the roster form. Next form we have is the set builder form. Now what is the set builder form? In a set builder form we have elements which possess a certain quality. For example, let's say I have a set represented by capital V. Now a set V will be defined as, let's say, X. Now X is what? X is the element of the set V. Now X will obviously possess a certain quality. So X such that X is a vowel of English alphabets. Now obviously in English alphabets we have a certain number of vowels, which is A, E, I, O, U, and this representation is named as the set builder form. Alright, moving on to the types of sets. The first set we have is the empty set. Now, what is an empty set? As the name clearly justifies the type of the set, a set in which no any element can be defined. For example, if I say a student studying in class 10th as well as in class 11, so you can obviously have an idea that there can be no student who is studying in class 10 and simultaneously is studying in class 11th as well. So that particular set is known as an empty set. The next category of sets we have is finite and infinite sets. We'll understand this using an example. Let's say I have a set represented by, again, let's say capital B. In B we have finite number of sets, like for example 1, 2, 3, 4 and 5. So we have only 5 elements in this particular set, which is B. And we can represent this in any of the forms, set builder form or the roster form. And if I need to define this set, so I can say that a set having natural numbers up to the number 5. So 1, 2, 3, 4, 5 are the elements of the set. Next is infinite sets. How can we define infinite set? Let's say I have a set A. Now if I say in a statement that the number of men in this whole world, obviously we can't count the number of men present in this whole world, so that is nothing but the example of an infinite set. Next we have our equal sets. Now what sets are known as equal sets? For example, again let's say we have a set A which consists of 1, 2, 3 and 4. These 4 elements, and we have a set B which consists of 1, 2, 3 and let's say 4. Again, if we observe these two sets carefully, we can notice that both the sets have exactly the same number of elements. In that case, we can say that set A and set B are equal sets. Next category we have is subsets. Now what is a subset? Again, let us consider an example. We have a set A which contains 1, 2 and 3. Only three numbers. We have B, which has 1, 2, 3, 4 and 5. Now clearly we can observe that every element of set A is an element of set B. Therefore we can say that A is a subset of the set B. This is the symbol which represents the subset. Next is the power set. Again an example. Let's say we have a set A, 1, 2, 3, 4 and 5. Alright, let's say we make this somewhat more simplified. So we have a set A having only two numbers, 1 and 2. Now if I would like to define the subsets of this particular set A, the first subset is 5. 5 means nothing. Second we have is, let's say 1, which is again a subset of A. We have only 2, again a subset of A. Then we can say 1, 2, which is also a subset of A. Now the set of all these numbers, a set of all these subsets is known as the power set. So the power set is the set of all the subsets. That is the power set. Now the last type of set we have is the universal set. Again, let us consider an example. Now, we are always interested in looking for natural numbers. So natural numbers are 1, 2, 3, ... up till infinity. Now in this particular set we have multiple sets. For example, we have a set of prime numbers, we have a set of even numbers, we have a set of odd numbers. Now a set of prime numbers, which can be again 2, 3, 5 up till infinite. Even numbers 2, 4, 6, 8, infinite. Odd numbers 1, 3, 5, again up to infinite. Now all these sets are a part of a particular set, that is the set of the natural numbers. So we can say that n is the universal set in this case. So I hope you have understood the basic fundamental of sets, its representations and its types. So to learn more, stay tuned. Thank you so much.